always a lot of fun to be the last speaker at a very busy day at a very busy conference. So let's see how that goes. And on that positive note, no matter how hard you try, how much effort you put in, how many times you try to rebalance your data set, the moment you deploy your model into the real world, it is bound to misbehave. Maybe not immediately, maybe after a few weeks, a few months, a year, but it's bound to misbehave. And perhaps one of the best examples of that really showcases that this would always happen is OpenAI. Back in 2016, when it was first founded, one of their main ideals was to make sure that whatever they design, especially when it comes to generative AI, will be good for humanity. And they actually put a lot of effort to make sure that this happens. So we all know ChatGPT. I think everybody has been talking about it. GPT, transformers, whatever. It's been like one of the major themes of this conference. So this is what happens when I ask ChatGPT to write a bio about me. First of all, it figured out that I'm a she, so that's usually a good start. And then based on that, it created this very impressive, very positive, and slightly poetic bio about me because it thinks I was born on an autumn day. Problem with this is that almost none of this is correct. There are two things that are correct. I am indeed Bulgarian and I have a PhD. Everything else, very positive, very impressive, but not correct. The problem is that this very positive overview suddenly kind of entered into murky waters because at one point they decided that I must have struggled with a lot of anxiety and depression because I'm a woman in a male-dominated field, which, again, not correct. I am a woman in a male-dominated field, but I've never had anxiety or depression. And by the way, this is an extremely derogatory stereotype that women in STEM face on a daily basis. So this is not a one-off example. We've seen multiple examples like that where ChatGPT either hallucinates, is incredibly biased, exhibits harmful biases, and so on. So the normal kind of, the immediate reaction of OpenAI to this was to play sort of a game of whack-a-mole and try to guardrail everything. So instead of trying to fix what the problem is, what they did is they prevented you from asking questions. So this is a very nice example of what happened with GPT-4 in the very early stages. So if you ask it, can you give an advice for my friend, whatever advice that is, it actually gives a very sensible advice. Or when you ask it to write countries based on their diligence, work ethic, and levels of education, it does that. And then after all the guardrailing when GPT-4 was launched, as you can see, it says, I cannot answer the question. And this was generally the approach that OpenAI took. And OpenAI is not the first or the only company that takes that certain approach. We've seen this approach particularly back in 2016 when Google Photos started, image recognition model started labeling Black people as gorillas. After a year, I'm sure some of you already know the example, but after a year of trying to figure out why this happened, the solution they came up with is to remove the label of gorillas. So even a gorilla would not be labeled as a gorilla. So now if you go to ChatGPT and you ask it to write a bio about me, it will tell you that it doesn't know, because it will not answer the question. But what this guardrailing and trying to play a whack-a-mole game kind of misses is the fact that humans are very ingenious, and they will always find a way to jailbreak your model. So this is an example of a very nice paper, which I highly recommend, of how they basically how they managed to jailbreak all the 4 main models in giving you instructions on how to destroy humanity, which is something if you go into ChatGPT and ask, can I destroy humanity? It will tell you, I'm not going to answer that question, but if you give it the right prompt, it will do so without any problem. The point of all this is that, as I said, no matter how hard you try, no matter what lofty ideals you put into it, or how many whack-a-mole games you try to play, every AI model that is out there in the real world, into the wild, is bound to misperform. And the thing is that whenever we talk about misperformance, we always talk about ChatGPT or Stable Diffusion or generative AI, and we're talking about how these things, once they get really into the real world, will end like working conditions, or it will end humanity, or all these kind of doom and gloom scenarios, which have some merit. But what this discourse misses to acknowledge is that even very simple models misperform, and they can do so on colossal scale. So let's go back to 2016 when Microsoft released their first Twitter bot called Tay. And what Tay was supposed to do was to interact with people on Twitter, and nothing I'm assuming you already know how this would go. And interact with people on Twitter and sound like a millennial while doing that. And the thing is that just didn't come up with the idea. They actually used a relatively simple NLP model to do that. And the model itself was based on a very, very successful pilot in China, where everything worked fine. And in order for them to develop the Twitter bot, they actually worked with a lot of writers, with a lot of comedians to make sure that they sounds the right way. So all this effort led to the proverbial hello world with, of course, the stereotypical multiple O's and multiple exclamation points that are very typical for millennials. And in just a few hours, this hello world positivism of a millennial turned into conspiracy and an aspiring Nazi propaganda territory. But what they did was essentially what it was supposed to do. It was supposed to learn from humans and sound like a millennial while doing that. But I think all of us can agree that Microsoft was not exactly pleased with how it went about doing the learning from humans and sounding like a millennial. So let's go even further back in time to 2013, when Knight Capital, an investment firm on Wall Street, decided to use a very simple flash trading model to basically execute all its trades. So they spent a year trying to tested all the models, tested all the different types of models, collected the right type of data. They applied all the different regulations, financial regulations, because the financial sector is actually very heavily regulated. And then they deployed the model. The model was live only 45 minutes, approximately. In these 45 minutes, it started overbidding on stocks that it was not really supposed to bid, which led to more than $460 million loss for the company, $12 million additional fine. And in order for the company to avoid bankruptcy, they had to sell to Goldman Sachs for pennies on the dollar. And what it turned out, why it actually did that, is because it interacted with a practically defunct system that nobody used since 2003, and basically people forgot that it existed. So the moral of the story of all these examples are, first of all, every model misperforms. But even if we try really hard, even if we put all the effort in, we cannot really predict all the ways in which a model will perform or misperform. We cannot really prevent it because there are too many variables that we cannot really account for or we cannot really know before we actually deploy it. But what we can do and how we can actually try to approach that is to mitigate. Now, nobody really knows exactly what would be the best way to mitigate things. One potential approach to do that is by trying to decode the hidden feedback loops on time and then mitigate these feedback loops. Again, nobody knows exactly what would be the best way, the most optimal way to do that. But here's so I'll try to propose a relatively simple approach on how we can do that. So to kind of put things into context, let's think of a fictional case. So imagine we are a bank, because all banks, of course, use a lot of AI, and we want to use all the data that we have to decide whether someone is eligible for a credit card or not. And because this is a very simple case, and we are talking about very simple models, we are going to use a very simple classification model, which basically says, yes, you are eligible for a credit card, or no, you're not eligible. So how do we go about decoding these feedback loops? Obviously, first thing we need to do is to understand what the deployed model is doing. So I think throughout the conference, multiple people have talked about different types of metrics that you can do. Obviously, for classification models, we have a standard set of metrics that we can use to understand whether the model is drifting and how exactly it's performing. Here in this fictional example, we are using F1 score and p-values, and we're trying to detect the drift. You know that. But trying to decode hidden feedback loops and looking only at the model is like looking from an impressionist painting from really up close. Sure, you can see colors, you can see strokes, you can see some sort of texture, you can see shadows, you can see movement, you can see many things. But only when you take a step back can you actually see that this is a Van Gogh painting. You can see shore, you can see two people, you can see a river, you can see a bridge, you can see light, you can see that it's night. You can see so many different things that you can really not see from if you're too close to the painting. So what we need in order to decode these hidden feedback loops is to find a way to take a step back. One way to do that is if we try to understand what is the impact of that model to the overall system. So again, because this is a very simple fictional case, we are going to look into a business indicator like the revenue. So for instance, we're going to, let me check. Yes, okay. So for instance, we are going to check how the performance of the model impacts the revenue. So in this specific case, you can see that the model is performing really well. So the F1 score is relatively high, and yet the revenue is dropping. So this could be an indication that something is wrong with the model. So immediately this becomes one entry point for you to try to explain what is happening and why is it happening. Once you have this kind of systemic overview over things, you really need to understand how these two things impact each other. How does the model impact the system, and how the system impact the model? So one very simple way to do that is to basically overlay the two things, the two performance indicators, and to identify the time intervals in which the two impacted each other the most. And of course, once you identify these intervals, you go around and try to see what exactly happened with the model and with the context, with the system, in order to understand what happened. And this is what you see under. And what that would allow us to do, that allows us to do basically this overlay and trying to identify the different time intervals in which these two things impacted each other, is to deal with one of the biggest problems that we have when it comes to online data, which is delay of ground truth. Meaning we know what the model is behaving in a certain way, but we can see the impact of the model only after hours, days, weeks, sometimes months. So it becomes incredibly important to identify the moment in which your model performed or misperformed and how that impacted the model, impacted the system, and to understand what exactly happened there. So that becomes incredibly important thing to pay attention to and try to strive for. But as we saw from, let me see, okay. But as we saw from the Tay example, performance is very context dependent. So Tay, the model that was behind Tay, performed extremely well in China, so that was very good, but it performed really poorly on Twitter. Now, there are multiple reasons why it might have performed very bad on Twitter, and a lot of people say, obviously, if you put something on Twitter, we know what is going to happen. Some might call it a dumpster fire. That's up for discussion. But performance is very context dependent. So for us, it becomes incredibly important not only to understand how your model impacts the measurable system, the business impact, but how the performance of the models is interpreted by humans in the context. So here, expert human feedback becomes incredibly important, and not only in the sense of a reinforcement learning human feedback, where you use basically humans to label data, but also you actually get a contextual understanding of why humans think the model misperformed or performed in a certain situation, which allows us to kind of lift off, extract certain types of features, certain types of important metrics that you need to pay attention to, first of all, but also it will allow you to understand what kind of, perhaps, certain objectives that you need to embed into your model, or even change the overall objective of your model altogether. So, all this, the combination of all this, and trying to understand not only what the model is doing, but how it impacts the system, and how is this performing within the context, and why is it performing the way it is performing in that context, becomes incredibly important foundation for us, not only to try to mitigate things, but slowly to predict more and more. Of course, we would never be able to predict everything. I don't think that's ever possible. Otherwise, every one of us would be a fortune teller, and fortune tellers would actually not be quacks, and it will work. But it will provide us with a very solid foundation to deal with unexpected situations. Doing so will allow us to stop playing a game of whack-a-mole and trying to basically prevent people from asking important questions and deciding whether someone can ask a certain question or not, and instead focusing on decoding this hidden feedback loop so humans at the end can make decisions on time. Thank you.
Thank you, Niya. So we have some questions for you here. Thank you. So the first, one question, please write more questions. One question I have here is, how can you identify when a drop in revenue is due to the model misperforming versus a shift in the market, so some external
factor. How can you perform?
How can we identify, for example, if you're looking at a drop in revenue, which is one of the metrics you proposed as an example, how can you identify the cause for this revenue drop? Is it the model or is it some external factor?
Yeah, so first of all, you would obviously first thing you would go and you look into the model and you see whether you have certain data drifts or you have like a shift in the type of customer space that you have. But one of the most important things you would go and do is this contextual understanding. You would go to the experts because they actually have a lot of experience in understanding what happened and whether certain market, why the market is changing or not. So this would be one of the most important things to, and where human feedback become expert feedback or whatever we want to call it, becomes one of the most important things.
Okay, so I have another question here related to the example you presented. It has the acronym SEIA, and the question is, what does it stand for?
The what?
SEIA. So SEIA.
Oh, it's like an internal product. Sorry, I think I should have blurred the logo. Sorry.
Okay, so now another question. How to connect model performance to business outcomes in complex systems? Tricky to connect decision to the overall bottom line, and in delayed feedback scenarios when the decision only has influence days or weeks down the road.
Okay, so there are multiple different ways, and I think it's again this type of business, and trying to understand how your model impacts your system. It's very well, it's a horrible answer, but it's very context dependent because every business has a different way in which they measure their performance. So that's one thing. The other thing is, unfortunately, very few businesses actually measure the performance of their AI models and whether it has actually positive impact on their business or a negative business impact. A lot of companies just use AI because it's everybody should be using AI or whatever. So nobody really knows what exactly it's their impact. So this is actually one of the biggest problems that are currently happening. Well, not problems, but challenges, because nobody really knows what kind of metrics we can use to measure the performance, the business impact of the model. One of the things that we are, for instance, currently working on is to use this human feedback and to kind of lift off the answers from that human feedback to understand what kind of metrics we can actually use to measure the performance, because there's a lot of knowledge within the people who are. So if you think about the example with the bank, so you have a lot of credit agents that actually understand very well what is going on with the market. They understand very well their customers' behavior. It is perhaps biased. It is a very limited view, but they have a very deep contextual understanding of what is going on. And if you combine enough contextual understanding of all these different people, you can actually lift off certain types of metrics that will allow you to identify the potential impact, business impact your model might have.
Okay, thank you. So another question here is related with these feedback loops, and if you think that being too concerned with finding the feedback loops can make the data team stop progressing, because there will be always new things coming up and they will be thinking what to do with this.
It depends on how you define progress, right? So it's like, what is a progress? To me, a progress is you need to make sure that your model and your solution performs better and that it doesn't create anything bad. So if we define that as a progress, then this actually allows you to progress faster because it allows you to identify challenges, it allows you to identify potential problems, but also opportunities, because you might see certain things that you haven't really considered based on the interaction between all the different elements.